Hi, everyone. So welcome to the panel. My name is Minerva Tantoko. I'm the first ever Chief Technology Officer of New York City. And our panel is called Computer Science for All, Putting Students in the Driver's Seat. So since Sarah did a great job introducing our panelists already, I won't go over that. But once again, we have Debbie Marcus from the Department of Education, Michael Preston from CSNYC, and Matt Farber from Valley View Middle School. So thanks very much for joining. And really the topic today is about CS for All. Here in New York City, we launched a Computer Science for All initiative, which will provide computer science education to all New York City public school students within the next 10 years. I myself grew up in Flushing, Queens, and went to all New York City public schools and have been a practitioner of technology for 30 years. And I'm really looking forward to hearing what the panelists have to say about CS for All. So why don't we get started with Debbie Marcus.
Hi, good morning. I'm Debbie Marcus. I'm the Executive Director of Computer Science Education in the New York City Department of Education. I've worked at the central administration of the DOE for the past 10 years, and before that worked in educational technology, helping teachers bring technology into their practice through a variety of different nonprofit organizations. As Minerva mentioned, I'm leading New York's effort for CS for All, which was announced in September to bring computer science to all 1 million students by the year 2025. We're doing this because we really believe we have three imperatives. One is an educational imperative, that good computer science education is inherently project-based and engaging and builds problem-solving and critical thinking skills that all of our students need to have. Second is an equity imperative. Right now, the majority of students who have access to computer science education are predominantly middle class, predominantly white and Asian, and predominantly male. And we really need to change the face of computer science education K-12 and also the pathways for higher education, as well as jobs in the tech sector. And the third reason we're doing this is to change the face of the tech sector in New York City. The tech sector is the fastest growing sector in the city, not just the tech sector, but also tech jobs in other industries. And we really want to make sure that the face of those sectors look like what New York City students look like, and really taking advantage of the human capital that we have inside of the city rather than always looking elsewhere to bring folks in. We think of computer science broadly. It's not just programming. It is programming and physical computing and robotics and really helping students create with technology. So we look at a pretty big tent view of computer science. And last, just that we are approaching this as a teacher training effort. We have to work with, we believe, about 5,000 teachers over the course of the next 10 years to retrain our workforce so they can become computer science teachers and bring our students a really important subject area.
Great, thank you so much, Debbie. I might add maybe even one more sort of the economic imperative, because the U.S. Department of Labor recently published that there will be 1.4 million tech jobs available in the United States by the year 2020, but our educational systems are only on track to fill 29% of those jobs. So I think in order for us as a country and as a city to compete economically in the digital age, it really is an imperative for us to train our children in the skills that they're going to need to participate. And to talk a bit more about CSNYC and the great work that you're doing, Michael Preston.
Thanks. Good morning, everybody. I'm Michael Preston. I'm the Executive Director of CSNYC, which is shorthand for the New York City Foundation for Computer Science Education. We're a relatively new nonprofit. We were founded by tech investor Fred Wilson, who several years ago was struck by how little computer science was being taught in the New York City schools, while also thinking about the constraints on the talent pipeline here for tech companies and startups and really the tech sector broadly, as Debbie mentioned, across other sectors. When we began our mission, we established ourselves in order to bring computer science to every public school in the city, which several years ago seemed like a more outlandish notion, but here we are a few years later working together to make it happen, which is very exciting. By our third year as an organization, we had helped the city start two new public high schools focused on teaching computer science and software engineering to all students. So irrespective of academic background, their ability to go to these schools and get a really rigorous and meaningful learning experience across 4 years is baked into those schools, as well as a host of other programs based at the Department of Education and supported by nonprofits and universities across the country. What we've done really is try to build on a few things, a really established computer science education research base and good work happening elsewhere, and then a deep partnership with the city now that was formalized last September when the mayor announced CS for All, Computer Science for All. Other things we do, we convene communities. We have a teacher meetup that we run monthly that is now 1,800 members strong just in New York City. We work with the tech industry, with higher ed. We're working on pre-service pathways, getting industry to really believe in and engage in the work in schools. And we are also working on building out K-12 CS Ed research, which is, even though I just said it was a foundation for our work, there are still a lot of open questions for us to answer together. Thank you.
Great, thank you. It's a wonderful example of a public-private partnership that's really working well with the city. And our final panelist is Matt Farber. You can talk to us about what you see on the ground and the relationship between Computer Science for All and games.
Sure, I'm Matt Farber. I'm a real-life teacher. I'm actually in the classroom. Yes, I'm not photons. I'm not an avatar. I'm real-life working teacher. So I'm representing that. In addition to being a classroom teacher, I teach social studies. So I don't teach computer science. I teach social studies using computer science as a tool to support the curriculum, which includes games, the systems of games, and the design process, which we'll get into. In addition to that, I just finished my doctorate in educational technology leadership. And in that role, as in my classroom teaching, as in my work blogging for Edutopia, I research what works in education, what works as far as in the field, how things look in the classroom. Over the years, I've used many of the Games for Change Games nominees and winners of Games for Change awards in my classroom, including the ones that are upstairs on display. Oh, one more thing. Sure. I also this year I've been working with the Movable Game Jam. I see Kevin out there. Hi. On bringing games throughout New York City. So as far as that entry point goes.
Great, thank you so much, Matt. And so just for, to get the conversation going, so Debbie, what's unique about how New York City is rolling out CS for All? We heard about the national program this morning. Tell us a little bit more about New York's flavor.
Sure. So a lot of different cities and states across the country are expanding computer science. They're either answering the national call for CS for All or have been doing this for the past couple years, really trying to think about how to expand computer science education to all of the students in their cities or states. And what we're doing in New York is a portfolio approach. We recognize that computer science could be taught as a standalone class. It could also be taught, I think, as Matt articulated really well, is that it is a tool to also integrate with other content areas. So we see in social studies, we've seen a lot of computer science and math, computer science in science with data modeling, computer science and art, and that it doesn't necessarily have to be a standalone class, that we really want to look at it in an interdisciplinary way. And so we're providing a range of training opportunities for our teachers so that they could either go deep into computer science and eventually teach a multi-year sequence in computer science, and or bring computer science into their math, science, social studies, art classes. And we're letting schools make the decision about how best to bring computer science to their school community based on their teaching capacity, based on their student and family interests, and based on how to align that to whatever their mission and vision is in their school. There's 1,600 schools, more than 1,600 schools in New York City. They have wildly different populations, teaching capacity, interests, and school communities. And so we really want to make sure that schools can make the choices that make sense for them, and it's our job to provide them with the resources and the professional development and the training opportunities so they can make that happen.
Debbie just said it all quite well. And I think what's fun about this too is that we're engaging an active community here. There were already I mentioned some work that we had seed funded that had already put CS in about 150 schools around the city, and engage what you might call an ecosystem of organizations that provide really exciting and diverse CS learning opportunities in and out of school. And so part of the challenge and the fun is to try and merge those worlds where the Department of Education can thoughtfully match schools with interesting opportunities that meet the school's needs and interests, as well as preserve some of the authentic and kind of inspired work that's already happening out there in CS education.
Yeah, just to add, I think both Michael and I use we very broadly. The we providing this training is actually a partnership. We had 15 different organizations working with us providing training, as well as DOE staff providing training opportunities. So that portfolio of training opportunities are leveraging the great resources and talent that's happening from traditionally out-of-school providers, universities, as well as DOE staff. So thank you.
So, as I mentioned, I've been a technologist for about 30 years. I first started programming in the mid-1980s when there were about 30% female programmers in my class, and that number has gone precipitously down, and spent the next 30 years of my career in the private sector, often being the only woman in the room. So the question of inclusivity in computer science is near and dear to my heart. I really applaud efforts like CS for All in their ability to open up opportunities to more folks. Do you see, Matt, an opportunity through sort of using games as another way to open multiple points of entry for students who are using computers or learning about computers?
Sure. Computers I've done some work in my classroom. I'll share an anecdote as far as multiple points of entry goes. And I have in my classroom, we use Twine a lot, okay? I don't know if everybody's familiar with Twine, but in Twine you make interactive fiction stories, like choose your own adventure stories. And there's a light amount of HTML coding that goes on. A lot of it's copying and pasting things in. And I had a lesson where students were going through the history book as their content source, and they were selecting parts of the Revolutionary War and writing interactive fiction stories from second-person point of view. And around day 2 or 3, I scaffolded up their learning. I added some difficulty to it, and I showed them where they can embed pictures and where they can embed sounds. So they take the HTML code from the Twine wiki, and they copy and paste and kind of hack the code. Like changing this height and width of a YouTube video that you embed in a website. So around that time, I announced to the classroom, hey, guess what? You're all coding. And a girl came over to me, and she said, I hate coding. I don't know, why is it such a big deal that I have to move Anna 3 spaces so she can meet Elsa? Now, this is a couple of months after Hour of Code, and that really raised a red flag in my mind that the issues with puzzle-based approaches. And it also recalled a Medium post that Mitch Resnick of Scratch put up around maybe last November or so with David Siegel about coding as self-expression. And that's what Twine really did for the students. It became a means to self-expression. Not that there's anything wrong with puzzles, but puzzles alone will only take you so far. And going a little bit further, I've had some conversations with, for instance, Allison Mishkin at the STEM Challenge about this, about the words themselves being loaded. So computer science, coding, gaming, those are loaded words for kids. You say that to anybody. If I say that to my parents, they'll have a certain image in their mind of what a coder is doing. They're in their basement drinking orange soda, furiously typing in ones and zeros or something, right? So in my classroom and in clubs I advise, we have multiple points of entry. So it could be storytelling, it could be game design, it could be pixel art. Any of those elements are part of the overall scheme of coding. And those are all excellent points of entry. So something to be wary of.
So what can the gaming industry do? I mean, where can the gaming industry or games in general be of most help in terms of supporting computer science for all? That's to any of you. Yeah.
Not to hog the microphone. So the gaming industry, in my opinion, can be supportive with communities of practice. So, and when I was in my dissertation research, I looked at 3 high-end using game-based learning teachers, and a couple are in the room. And their students are all parts of communities of practice. And those communities of practice extend to game design companies as well. So bringing them in touch. Using games in a context of project-based learning and not having to reinvent the wheel. If you look at like the BIE.org, which is the Buck Institute of Education, they have an 8-point checklist of good project-based learning, including having an authentic audience and giving students choice and voice so they can publish online. Reaching out directly to game designers. I reached out directly to Ted Alspach when I used One Night Ultimate Werewolf in my classroom. I've reached out to other game designers. Jesse Shells, one, by the way. He learned computer design in the school that I teach back in the 1980s. So I recommend that students and teachers reach right out to game designers. I find them to be quite receptive.
Building on what you said earlier about many points of entry, or I like to call them on-ramps, I think that not all kids are motivated by games, but often they're given opportunities to play them. And what I'm seeing increasingly in the game space mirrors what I think designers of computer science learning environments or platforms are getting to, which is scaffolding or visual approaches to teaching concepts that make the overhead of learning how to code a little bit less, so that you can kind of get to the concepts quicker and not get bogged down as much in the things, the syntax that might come a little bit later. And so unpacking that stuff, making it accessible for kids to interact with and modify things behind the scenes or under the hood, so that they feel more in control and have some agency. You know, to your point about the Mitch Resnick's article about self-expression, I think when kids feel like they have some voice or control in the matter, it's more motivating, even if they're not totally interested in playing a game that's formally recognized as such. And so I think it's encouraging. On the flip side, I think it's also important to make sure that those experiences are not that they're leveraged, that kids' learnings are that they at some point understand what they're doing. Like you had your reveal moment where you said, by the way, you're coding, and got an intriguingly negative response, right? So kids can come at it in a lot of different ways, whether they know it or not. And I think giving them a chance to maybe revealing it a little bit later. Oh, like when I'm trying to fool my kids into eating vegetables. By the way, you just ate a vegetable dumpling. Oh, no. So.
I think also, building on that, we're seeing really interesting things out of organizations like Games for Change when they're thinking about the topics of the games that students are creating. So sometimes games is a loaded idea, both for teachers and parents and for students, about what that means and who's into games and who's not, and whether or not it's learning. And so I think pairing that with civic-minded projects, so things like the Games for Change Challenge, where the topics were helped created actually by City Hall, and things that matter to the city and topics that we needed to tackle. They become more meaningful for many students who may not see themselves as gamers, but they can see themselves as problem solvers or solving an issue in their community that's real. And we've seen a lot of, especially the girls that we work with, connecting to those problem-solving, civic-minded themed projects, which has been great. And I know we actually had one of my staff members gave a talk yesterday on a hackathon that we did. And we've been finding that we do a lot of hackathons, but the civic-themed hackathons are really engaging a wider group of students.
Yeah, I totally agree. Coming from City Hall, I think, it's a great way to engage both what the kids are thinking about, but also coming up with with solutions that they might be able to see in effect, on the city streets someday. So there's that reward. So what have you learned from other, computer science programs, either around the world, around the country, and what barriers do you see? What are the biggest challenges, and how would we address those for CS for All?
I'll take a stab. One thing things that we've learned talking to a lot of states and districts who are trying to do this, that really helped inform our portfolio approach has been that it is hard, especially with a district of our size, to have a one-size-fits-all approach. Either some have brought in an outside partner and said, great, bring CS here, and that's done some wonderful things, but then there's nowhere for the district to take that. And so we're really looking at both bringing a lot of outside capacity or outside partners, and then building internal capacity. So we are hiring central DOE staff in the bureaucracy whose jobs it is to support schools in computer science, as well as opening up an array of training opportunities by innovative professional development providers and innovative programs, and that match so that they can learn about innovative projects, learn new skills and concepts, but then there's someone 3 or 4 years from now who's still here and still working with them and helping them build their skills and connecting them to new opportunities and thinking about what the field looks like 5 years from now, and continuing on. And so I think, being not the first in the space, but early in the space, we can look at what's happened elsewhere and think 3 or 4 years down the line, because we're seeing what the other districts are experiencing.
I can think of 2 examples to build on what you're just saying. One is computing at school in the UK. The UK is several years ahead of us in terms of building up computer science as a national goal and a national curriculum. But one thing that they've done very well is create communities for teachers to be part of. As much as we talk about this as an initiative that seems to be coming from the Department of Education and formal partners, is really a lot of the innovation and really interesting learning happens at the level of teachers who implement things in the classroom, adapt, bring in new ideas, and then create something that's worth sharing. And so the more the teachers who may feel isolated in their schools see themselves as part of a larger community, whether it's in their local neighborhood or district, or as part of the Computer Science Teachers Association, which is an international body, that's one very important thing. A second thing is in Israel, for example, which has an extremely high level of computer science taught in K-12, they've really partnered deeply with the local industry, who are obviously very eager to employ the graduates of those programs. But what's interesting about industry's engagement isn't just so that they're reverse engineering their future employees, but that they can contribute meaningfully to what learning looks like and make sure that it's authentic. And in some ways exciting, because for kids it's connected to the world that they experience outside of school. Cornell Tech here in the city hosted a guest academic from Technion in Israel, and she was extremely helpful in helping us kind of think about ways to engage our tech sector here.
And I've encountered the obstacle of the child who's really good at playing school. So when you're going through computer science in, let's say in a project, and they're using maybe Scratch or any tool set to deliver a project, the student that's good at the game of school, semi-air quotes, is used to turning in the perfect project, like the scrapbook that they went to Michael's and purchased all the pieces of, and here's my scrapbook. Whereas the iterative design process is the 21st century skill that is part of the entire reasoning behind it. So the grading becomes interesting also. So students are graded on what's modeled on the real world. So their designer diaries they write, their postmortems they write up, their discussions, modeled on real life careers, the artifacts that they turn in. Not to have a working system necessarily. It can be a flawed system. It should be, especially a game, right? If you design a game, your first version is without being user tested or play tested, right? So that's a barrier to get past to students that are used to going through the system of always turning in the right thing. And for that to occur, there also has to be a culture of a safe environment to fail in class without it affecting your grade. And there also needs to be a high amount of student choice and voice for their projects. So they should have a suite of tools to use. Maybe they don't want to use Scratch. Maybe they want to use GameStar Mechanic or whichever they'd like to use, or Twine. That's the approach that we take in the Movable Game Jam initiative around New York. So there's usually an analog game station. There's, maybe interactive fiction tool station, or, different tool sets. And then the students have choice to migrate to what they want to do. Otherwise, too much structure and not enough play, there's not going to be any learning. Vygotsky wrote that play creates the zone of proximal development. So if it's too structured, it's not going to have enough learning taking place.
Yeah, I totally agree with that. I mean, the full disclosure, when I was first starting to learn to program, when I was 19, 20, I actually turned my first assignment into a game just to make it more interesting for myself, right? It was just about some boring nesting statements, and I had to demonstrate that I understood the concept, but I turned it into a text-based game. And, I think part of the success in that is the teachers being empowered in that way, to have that freedom as well, because we talked a lot about the students having the freedom to fail. What are some of your thoughts on, giving teachers that empowerment to be able to teach new ways of thinking?
I could answer that real quick. I kind of went back in the literature on this, that teachers, risk is a perception, so it's not always realized. So teaching is isolationist in a way. I'm in my classroom, and most of the conversations I have are with 11 and 12-year-olds, which is great if I want to learn about new games or, how to do something in Roblox, right? But to learn about what other teachers are doing next door, it's kind of hard. Twitter has been amazing for that. There are, maybe hundreds of Twitter chats that go on, and I partake in the Games for Ed chat with Steve Isaacs, who spoke yesterday about Minecraft, and he's literally always on Twitter. And when I observe teachers in the classroom, including Steve, they will take photos, behind the head shots of their kids coding and programming and working, and share them on Twitter almost immediately. And they get the social capital of, the hearts. Really is empowering, There are people I know in this room where I've met just from Twitter prior to even showing up here today. And that's empowering and encouraging. So embracing social media like that helps.
I think that speaks to the importance of community of practice, which you both raised.
Right.
That teaching can be very isolating, and especially if you're the only teacher in your building who knows anything about computer science, it's especially isolating.
The Lone Ranger.
Exactly. And so, could do something with that. So I think in New York City, especially as we're trying to work with 5,000 teachers, we have an embedded community of practice, both live and online, that we can be taking advantage of. We've been running a program called the Software Engineering Program for the past 3 years that has about 40 teachers who've been spending 300 hours of professional development with us over the past couple of years, learning a multi-year CS sequence. But they've talked a lot about how much that community itself has been so important for their work. And they now actually teach, they're going to be teaching our next cohort and teaching themselves and continuing that learning. So I think that's critically important. I also think we have a responsibility from a district or administrative perspective to give room for that failure. One of the reasons CS for All in New York is a 10-year runway is that we have to recognize that it's not something that happens overnight. And you don't just go to a one-day workshop and suddenly you're a CS teacher and you can do everything wonderfully. You have to be able to learn something, try something, see how that goes, try again, fail, try again, talk to others, come back, learn more. That cycle's important and it takes a long time, and so it's not something that can happen overnight. So lots of folks ask me, like, oh, well, why does it have to take 10 years? That's ridiculous. It actually is not to bring a new subject area to the largest school system in the country, and I think that protecting that space for teachers is critically important.
It's pretty weird to talk about failure as a value when you're talking about school. But I think of it on 3 levels. One, obviously, is students who are conditioned never to fail in school. And so you have to think about how you can help onboard teachers to this kind of learning and creating a context or learning environment where it's okay for things not to work right, and the value and the purpose of the work is actually to continue to build on, iterate, through testing and revision, get to the point where things work, and maybe it will never quite work the way. In fact, you might be revealing to students that life is full of imperfect systems and that you're always working on, which is also a good thing to learn. So teachers and students both need to, I think, be inducted into that culture, and computer science is a really interesting opportunity to do that. I also like to think about the school level, where we're bringing many, many schools on board to this new subject area, new way of teaching, and if the thing that they invest in initially turns out not to be the right fit because of the way their school runs or the teachers involved, that there are other opportunities for them out there, that this field is wide. There are different ways to integrate into your school. So coming back to the well and trying something else is going to be an opportunity for them that they can build on things that don't work. We'll learn a lot from that as well so that we can be better at guiding schools in the future.
Great. So, for me, I get to, in my job, one of my pleasures is to, judge a lot of hackathons and meet with a lot of young folks. And I'm so deeply impressed and full of hope for the next generation of kids. They are just incredibly smart. And just yesterday, at another competition, one of the young folks wrote a game to teach math. And it was incredible. Another student wrote one to help people suffering from Alzheimer's. It was a game, but to help them remember people in their family. It's just like incredibly touching, amazing stuff when you talk about games for civic change or games for good, games for change. Before we open it up to questions, I wanted to leave you all the opportunity sort of make a final statement about the importance of CS for all and how games can play an important role in that. As I've said, it's such a critical issue for all of us. Do you want to start, Matt?
Sure. I've been using the games as a model approach in my class. So my students will play a game to learn or to get a feel for the literacy of the game. So two I've mentioned. One was One Night Ultimate Werewolf, which is a shorter version of Mafia, basically, where you accuse each other of things. They played that game, and then I have them remake the game in teams about the Salem witch crisis. And I give them above grade level material. I give them high school plays like The Crucible, even though they're in 7th grade, and they decide which characters would fit which, like Rebecca Nurse might be the troublemaker card or something. That really gets them a feel for the system of the game. And then another I used Twine was after I used Mission US. So once they understand how the choices play out in a game, then they make their own version of it or their own take on it. And this cuts to something a little bit deeper, which is historical empathy. And there was a great talk about that yesterday on empathy. And I had a talk also about a month ago with Mary Flanagan about empathy in games. And she shared a study with me from a Yale researcher, Gina Roussos, about how when people who had empathy played the text adventure game Spent, which was a Games for Change game a few years ago, their empathy actually went down because of the choices in the game felt like poor people were choosing to be poor based on their choices, based on the meritocracy that we're in. But people that were watching other people play the game, their empathy went up. So, this to me seemed like a moment where my students should not just play a game and have historical empathy of how people felt in the Revolutionary War, but to give it an opportunity to make their own games. So they're mixing in user empathy or player empathy along with the stories that they're telling or the interactive systems that they're making.
I guess I want to draw together some themes that we've already discussed today. I see Games for Education or Games for Change as aligned in many ways, if not integral, to the movement we're starting with computer science, in that we're creating contexts that are more student-centered. The panel's putting students in the driver's seat. And I think the idea that it's about students' connectedness, authentic experiences, you said voice and choice, things that allow kids to make decisions about their learning and the outcomes, and the social connectedness of it, I think, are all really important drivers of the work that we're attempting to do here. And games are a wonderful on-ramp to that world of learning. And it's interesting, we're talking about empathy here. You know, we're living in a time of national and international political change that seems to be in need of people across the spectrum feeling empowered and like they have a voice and ability to make something happen for themselves. So I think if we're starting at in K-12, trying to adjust the system so that students are more prepared, not just to submit correct answers or memorize the stuff put in front of them, but to actually have some agency and understand how to make things work for themselves, that's a good step for us all to take.
I would just add to what everyone has said, which is that doing this work really is a partnership among our teachers, our nonprofit providers, our industry, our higher ed, and folks who want to get involved. So if you want to be a hackathon judge and experience what Minerva gets to experience, if you want to host an intern, if you want to get to know our teachers, we really want to connect both our teachers and our students to the real world so they can see where their learning can take them. And so afterwards, if anyone wants to get involved, please give me your card, let me know.
Oh, that's great, mentoring. So thank you very, very much. We'd like to just spend the next couple of minutes answering any questions from the audience. So please raise your hand, tell us who you are, and then we'll repeat your question because I don't think you're a mic. So we'll start with you and then you. Yeah.
Yes.
Okay, so I'll repeat just for the video here. The main question is about, are you getting what you need for the teacher pipeline, and what about non-traditional sources of teachers?
So in the essence of time, I'm going to answer it briefly, and then we should talk more after the panel, because certification in New York State is a lengthy discussion. But to your point, if we don't solve the teacher training pipeline question, we're going to wind up in 10 years exactly where we are now, which is needing to train the current workforce. So absolutely something that we are cognizant of and having conversations both with teacher training programs and ultimately the state. There is a certification question about who teaches, how they teach, and what they teach that needs to be solved both at the state level and then also from our teacher training programs, taking it on in earnest with or without the state acting. So I think that those are two very important things, and would love to talk to you more about non-traditional pathways into teaching.
I might add, too, that we, CSNYC, have been trying to work closely with universities around the city to think about possible models of teacher training. So in pre-service undergraduate and graduate, as well as extensions to certifications, since many of our teachers are already certified to teach in a different subject area, and so they may need to come back to school. So I think it's a combination of formal programs that are called CS education, as well as embedding technology and CS learning for all teachers who come through their schools. We're working on a white paper that's almost done and hope to publish that pretty soon.
And I'd like to say that teaching is a design science. It's not just delivering instruction, and teachers should look at themselves as designers. There's this concept of the learner's experience, like the user's experience, LX versus UX.
Great. And there was a question up there.
Yeah. Can you hear me okay? This is a question for Matthew. So when you teach game design, I imagine design is all about going deep, but a lot of traditional USA curriculum is very shallow and very broad.
Right.
So how do you deal with the conflict between those two philosophies?
Oh, well, there's actually no conflict. It sits very well at project-based learning, which is very well established. It's not always in every classroom, but project-based learning gives you an opportunity to go deep in the topic or subtopics. Now, what I found is over the years, kids would get different subtopics. So you'll study this, you'll study parts of a flower, you'll study parts of I don't know, whatever topics, right? Then the presentations might be kind of boring. You rely on the student as expert, and they give you a PowerPoint presentation and what they learned, and the other classmates are expected to just know it, right? When you're designing a game, you're designing a system, right? An interactive system. So if I give a child a T-chart, and one of the games a kid wanted to make was about the Illuminati, because middle schoolers are obsessed with the Illuminati. Illuminati confirmed everywhere, right? So they made stories about the Illuminati, fixed the Boston Massacre, right? So, you give a kid a T-chart and say, okay, which was historically accurate, which is not historically accurate, and they're immediately engaged in that system, because we're raising a generation of playtesters, right? My son's 5. He knows what an app update is. He knows what that means when it's like loading again, So they're expecting to be even more engaged because they're testing somebody else's system. So it actually enables them to go deeper on the subtopics.
I think we have time for one more question. I saw someone there. Yeah?
Is your question about computer science standards or other content standards? The question was about standards and how we're understanding the varying sets of standards that are being created. For those who are not deep in education policy, standards are adopted at the state level. We don't have national standards, although many states have adopted the Common Core in ELA and math. New York State does not have computer science standards. I don't know if New Jersey has computer science or tech standards.
On the spot.
Okay, never mind.
I don't want to check my phone.
I'll stay with New York City. But we have been looking a lot at what's going on nationally. So the CSTA has a set of computer science standards that have been out for a while that they are currently revising. And a group of organizations led by Code.org, but really a sort of national set of folks have come together to create a K-12 framework in computer science. And the framework is designed to work with the CSTA standards, that the framework is sort of a broader view of what the skills and concepts that students need to know, and that what the CSTA is working on is a set of specific standards within those broader frameworks. So as a city, we are beholden to New York State that does not have CS standards, so we're looking closely at those national movements, and we're actually working on a document that will probably take about a year to put out to give our guidance about what do we mean by CS in New York City. So as a guidance document, it's not a formal standard document, but that we're looking to align to those standards, but really translate for what does that mean in practice in New York City schools. So sort of take it at a much more practical level for teachers, but in terms of implementation, concepts, pedagogy, and examples of practice without being very directive about specific curriculum.
Clearly, we need to communicate better what is computer science. The Google Gallup surveys that have been released over the last year show that there's a lot of confusion about what is computer science, both among the families who have a high degree of demand for it and the school principals who have a low demand for it, given that they're already handling too many things as it is. So articulating clearly what this broad domain is so that it's not too narrowly defining, but also not enabling making a PowerPoint to count as computer science is important, and then communicating clearly to schools and districts so that they can make a plan and implement successfully is really key too.
So we're out of time. I apologize, but we'll be around for you to talk with our esteemed panelists later. Thank you so much. Please join me in thanking Matt, Michael, and Debbie for the important work they do and great insights.
Thank you, Minerva.
Thank you.
Thank you.
Thanks very much.